Let's look at techniques to help students learn about equivalent fractions. We're using free online visual tools from Conceptuamath. This is the equivalent fractions tool. And I'm going to demonstrate how to use this effectively in a 5 to 15 minute group discussion. Let's see how I've got it set up. We see the three fraction models. They're all showing 2/5. Here's how I did this. I actually started by entering fractions right here. I just typed 2/5, 2/5, 2/5. And then I hid this part of the screen. We call it the fractions layer. So that's how I got it all set up. Here's how my discussion can start with the students. So we're looking at three fractions. They're equal. They're the same. They're all 2/5. And I can just declare that just to get started. I'm going to go ahead and make some changes to two of these fractions. I'm going to change the number of equal parts. I'm not going to change the quantity of the shaded area, but I'll go ahead and make this into 10 equal parts. I'm going to make this one into 20 equal parts. Very simple discussion. And then I can have the students work in their groups, in pairs, to describe what these fractions are. They represent the same quantity. And in so describing, we can also have a discussion about what equivalent really means. That we're representing the same quantity, but with different numbers. So I'm looking for the students to articulate 4/10, 8/20, and I'm going to help them in their discussions to come to that conclusion essentially on their own. Once they've articulated 4/10 and 8/20, I'll validate that by showing, yes, these are the numbers. But now we're going to take it another step. I'm going to show the middle layer. We call this the equivalence layer. And I'm going to help the students to understand that in both cases, we took 2/5 and multiplied 2/5 by a 1 fraction. If you multiply 2/5 times 1, you get 2/5. If you call the 1 2 over 2 or 2/2, you land up with twice the denominator, twice the numerator, twice the number of equal parts, twice the number of shaded parts. Likewise, 4 over 4, 4 times 4 times. It all makes sense. Now watch what I do. I'm going to unlink, and I'm going to have a student come up to the board and choose a different 1 fraction. And I'm going to encourage them to choose one that's going to be reasonable for us to work with. So 3/3 would be a reasonable choice. So a student has chosen 3/3. But the model and the number, the fraction, have not updated automatically. This is now more pair and group work in this introductory 5 to 15 minute discussion. So the students are going to talk about what's going to happen when you multiply 2/5 times 3/3. So what we want to have happen is the students understand that we're going to land up with 3 times the number of equal parts, 3 times the number of shaded parts. We still have an equivalent fraction, and then they can render that fraction as 6/15. And the software does allow for the check work function so they can validate their work. This is a very effective way to have a class conversation about equivalent fractions.